Hi, I'm Shannon Henry, an applications engineer here at EMA Design Automation. Today we are going to discuss impedance and how to implement controlled impedance in your designs. You learned about impedance in school, but how does it relate to PCB design? As a refresher, impedance can be defined as the ratio of voltage to current in the frequency domain, or the measurement of opposition in an AC circuit. Every component in a circuit has a corresponding impedance. In a PCB layout, impedance comes into consideration when routing. The traces are viewed as transmission lines. Why should you be concerned about impedance in your traces? With higher frequencies and smaller components, designs are becoming increasingly complex. It is more important than ever to preserve signal quality so your circuit functions as intended. This includes ensuring timing of components and reducing ringing. This is especially important if you are in the telecommunications, video, or computing industry. Impedance discontinuities can be the cause of additional noise in your circuit. When a signal travels on a trace and it encounters a change in impedance, some of the signal will continue, and some of the signal will be reflected back, causing ringing. This ringing can make your circuit unpredictable, but it can be reduced by matching the impedance. The first step in successfully designing with impedance control is to identify the nets with potential signal integrity issues. To determine which nets are the critical nets in your design, take a look at the edge rate versus the trace length. Edge rate and switching information can be found in the manufacturer's data sheets. If the source can complete the edge transition before the signal reaches the load, the corresponding trace could be problematic. Comparing the trace length and edge rate for every trace in your design can be time-consuming and tedious. Many PCB software packages perform signal integrity analysis, where you can automatically determine which traces may have ringing or reflection. Now that you have identified the nets, to prevent ringing and reflection, the impedance can be controlled physically within specific layers in your PCB stackup. You can perform the calculations by hand, or there are many impedance calculators to help save time. For more information on measuring impedance, be sure to watch our next Whiteboard Wednesday session from the PCB design experts here at EMA Design Automation.